Excuse me. Okay. Let's go. Oh yeah. This is for how to declare, how to define. I like define better because I don't really like declaring things, declaring objects without initializing them. I mean, I guess it doesn't really matter if your IDE or at least the compiler. I'm not sure which one it is. I'm not sure if it's VS Code that's bitching or it's the compiler that's bitching. But we can't use an uninitialized object. Like, let's see what the exact error is. What am I doing? Oh, ooh, not just declared. Oh, I don't even think I need IOStream. I could just increment it. Yeah. Using uninitialized memory. Meaning I'm not assigning a specific value to it. I am using what is there and adding something to it. The final result depends upon the information that's already there. So I'm using the shit. And this is the warning, but the error, I'm not sure if this warning is being generated as a result of it or what. But yeah, why was I talking about that? Oh, for yeah, it says that we declare a reference with an ampersand like this, but I don't like just doing that. One, references need initializers anyway. It's a reference to fucking what? It's not an object, so it needs a reference already. It needs something to reference. But then I could also get like a pointer, fucking integer pointer, and we'll just call it like that. X pointer, X reference, etc. No, okay, and cool. We only have warnings here. So, we can't declare or define an initialized reference. We can for pointer. Cool. But I could also say, hey, this guy gets the address of X, and then whatever. Oops. Something like that. So say, oh, hey, X exists. Hey, take the address from X. Cool. And then, oh, I can increment whatever the fuck value is there. Cool. Ways of passing info. I mean, so far I don't see any difficulties with understanding pointers or anything just yet. It seems more straightforward than how I was learning C the first time when I did for like 2 months or something, or a month, 2 months, I don't know, something like that. I had to learn C a little bit before starting Godot, but what really happened was that I started Godot, fucked up, realized I didn't understand syntax or anything, and I was basically just copying instructions like a fucking idiot. Without understanding anything, I was writing letters on a page without understanding what the fucking letters were. I was writing words on a page and paragraphs without understanding what a letter is or what the letters mean. I'm like, what the fuck is this, dude? Yeah, sure, you can talk out loud, and that's cool. You don't have to know how to write to talk. You can just talk. But for programming, motherfucker, to understand this shit, I have to be able to write this shit. There's no talking, writing. Bro, you have to write the shit. That's it. That's all that matters. It doesn't matter if I can talk and say, hey, yes, this and this and this. And they go hand in hand more than a language and letters anyway. Like if I speak English, people know what I mean. But letters and words or written language is a separate thing. They're exclusive. I mean, sure, you can speak written letters and you can write spoken letters, but they don't have to intersect. But the words here have to intersect with the idea of an object. I mean, I guess I could say all this stuff exists in memory and there's a way of storing it. I can have an object that stores where another object's location is, but it seems like to actually do anything with it, I have to write the shit. Maybe similarly to how if we have language and it's written, I feel like you have to. It's weird. I don't know. It's weird. All right. So yeah, pointers. Okay, I haven't really done anything with them yet, but oh, okay, cool. Always initialize them. All right, cool. Nice. Okie doke. Oh, this is or no, garbage. Oh wait, yeah, I have seen this. Wait, what? Much like, oh, much like the type of. Wait, what? No, 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 no. Much like the type of. There we go. Okay. I was like, I was in the wrong spot. Right? Okay. No, no, no. Okay. So, okay, we were significantly further down. Okay. I was wondering what was going on. Alright. Yeah, an integer pointer is a pointer to an int. Yeah, cool, cool, cool. It's important when talking about const, because if we're talking about a constant pointer, then pointer to a const. Oh yeah, isn't that, I think I found that out yesterday. When we have const int x gets 5. Motherfucker. Okay. And then we have an int pointer, xp, x. No sir. Can't convert from, from an int. From a constant to an int reference. In binding reference? So how does this reference shit go? I don't know. Oh, motherfucker, this is why. It's because I made a reference. I was wondering what was going on here. Okay. I cannot. Hold on. Yeah, it's having trouble on line 4. Yeah. Can't convert from a constant to an int pointer. Oh, wait. Well, motherfucker, this needs to at least be the address. I want to see that. There it is. Can't convert. Okay, can't drop it. Oh, well, yeah, I guess so, huh? If we have a const object, and I take the location of it and I dereference and change what's there, I shouldn't be able to do that because then we're changing the const guy. But I can make this a constant pointer. Boom. But I can make a constant pointer, which, oh, motherfucker. It's a warning. So how do I make, would you even want a pointer that can't be changed to look at something else? Because if I'm thinking of a const pointer, a pointer simply is pointing at something. It has the address of something else. And I could assign it all day and it's not changing anything. It's just holding where different things are. But maybe it's changing things because if other things are dereferencing what it's holding, then by changing what the pointer's holding, you're changing what the pointer, or you're changing shit at where the pointer's holding. So you could be changing other things if you're using the pointer, which you probably aren't. But is there a way to make a pointer not changeable? Why would you want that? Would you want that in a linked list? So if we have a bunch of integers and then we have a pointer to an integer and we only want it to point to that place, maybe you want an unchangeable array? I don't know. But okay, so you can have const pointers. I don't know how you make a const int, so a pointer to a constant. But so far, no const pointers. But there are const pointers, so that'll be fun. Yeah, so we can't mix and match. So if we have keyboard's too far. Yeah. No sir. Excuse me, can't get a pointer of an int and convert to a double. Yep. And I guess it's basically saying that this is an int pointer. Entity. Interesting. Same thing. Cool. Hold on, I got some shit stuck in my teeth. 1 sec. Thank God for toothpicks. I eat a lot of pepper, and pepper gets stuck in my teeth because I grind them, but I have a mouth guard, so I don't grind them anymore. Or rather, the mouth guard protects my teeth from grinding, but before, when I didn't know that, I had some little divots in my teeth, and they're just fucking big enough to hold pieces of pepper in there. So I get pepper stuck in my teeth. It's so annoying. Oh, I got lucky. Fixed it before, or stopped it before they got real fucked up. Okay. Yeah. So basically, we cannot have a pointer. There are no implicit conversions. I can't have a pointer to a double pointing to an int. The type of memory we're pointing to must match, or the type of object we're pointing to must match the type of object. Hold on. The type of object we're trying to point to must match the type of object we can point to, or that we say we're going to point to. It seems like it's kind of like pool, where you have to call a pocket and say, hey, I'm shooting in that pocket. I cannot shoot into that pocket. So sure, I can shoot into that pocket, but not in the fucking reality where I say that I'm shooting at that pocket. That's an int, that's a double. I say I am pointing to an int. Well, that's the int, motherfucker. You're pointing to a double. No, sir. The mafia comes behind you. Alright. Initializing a pointer with a literal value, with one exception. So is there some sort of R value pointer where it prolongs... Would it do that? Would it prolong the lifetime, maybe? Like if we say, hey, we have this R value somewhere, this temporary object, and I have a pointer to it. Well, if I have a reference to it, I can change it. Or hold on, rather, no, I cannot, because those are only const L value references. So I have a reference that's looking at it. We can't change it because it's a temporary object. We can't, I guess, access it to change it, but we can look at it. Cool. And it exists until the reference dies, and then it dies. But if we have a temporary object and I have a pointer, does it exist as long as someone's looking at it? I don't know. It almost seems like a reference, a const reference in that case is kind of a similar thing, right? Because I have a reference, a read-only reference, a const reference, so a reference to a const, or an L value reference to const for an R value, a constant, a literal. I can't change it, but I can look at it. I can say, hey, I don't know where you are. I mean, I could get the address of me to figure out where you are, but you exist. I got a thing that's looking at you. It's not an object, but it's looking at you. What exactly a reference is storing? Did we even go over that? It's not storing the address because it's a pointer. It's like I guess it's binding to it. So I don't really know what exactly it's storing. It's not storing the value, but it's kind of looking at it in a different way than... It seems like you've got a CIA guy or a Marine with coordinates to the target, and that is a pointer. But then you have a reference where there's like a spirit that is soul bound to the target. The binding in a reference and its referent is like soul binding, so it's a reference. Whereas the coordinates to something, and still being able to change it, just like a reference, change the reference, changes the referent, dereference and change what is at the coordinates through the pointer, changes what's at the coordinates through the pointer. So, and I guess in that case, it's not even through the... Well, I guess it is. It's like... Yeah, Maybe it isn't through the pointer. You're just storing the coordinate because you could have different things that, but you could also have different references. Okay, they seem pretty damn similar. So, just like in the beginning where we had a regular reference, we can't. Here. So we can't have an int reference to 5. But we can have a const int reference x, we'll say xr value to 5. No issues here. Issues here. Ow. What are you having? What is happening to you? Okay. It's like, I thought I just, built. I guess not. I didn't compile. Yeah. Must be an L value. Oh, there was a gnat. Oh, I already brought my trash out. Alright, I'm good. Excuse me. Okay. A gnat. Not a gnat. What am I saying? Oh, there's like a pimple or something down in there. Oh, God. Oh, it hurts. Alright. Can't have... This is an L value reference. Did I not even put L? Of course I didn't. L value reference to const. Any value. I mean, seems like. L value... Modifiable L value only. Okay. What was the point of that? We could... What if we did int... Oh, int pointer x to 5. Oh, the reference of 5, sorry. On constant. What if this was const? Fuck. Okay, didn't make any change. I have no idea. Okay. Could you have a pointer to a const? Hold it. Hold. Const int reference. Okay. X stores this L value, or it doesn't store, but it's bound to this temporary object L value that exists. As long as this reference does. So it's created, then it dies, but it's fine. Okay. Now, const int pointer xp to address of x. Oh! Oh shit! We can! Holy. Okay. So we can shoulder still. Gotta keep using it. It's getting better. Yeah, it 100% is getting better actually, because I can do that. It's not too bad. It's like a 2 out of 10. Let's get more. Just gotta keep going through it. So we can have a const int reference that allows us, or an L, or a const. Sorry. An L value reference to const can bind to an R value, temporary object. Okay? And I can point to that reference. It's like pointing to a remote control. I can't point to, oh, that's actually kind of similar to what it is. I guess if you think like, what is it called? The square kilometer array, the SKA, maybe? Something like that. I think it was something that was supposed to be built in Australia or Egypt or some shit. Some big neutrino detector that's supposed to detect this specific type of particle physics thingy that doesn't really interact with anything else, but maybe can be received in order to be Morse code or some sort of communication. So maybe it's a good way to communicate across the universe, because you can send those guys and it can just go through the sun maybe, and it isn't subject to gravity, so all you do is point that to where our planet's going to be in 1 billion years, and then boom, eventually your Morse code gets there and you don't have to worry about signals or any of this shit. Well, I can point to the square kilometer array. I cannot point to neutrinos, these temporary little things that are falling through the freaking world. I cannot point to them. I cannot point to a temporary object. Not even with a const int pointer. And there's no fucking like literal pointer or something like this as far as I know. I cannot point to the neutrinos. I can have somebody else who can examine and bind to the neutrinos bound to the neutrino, bound, L value reference to const, bound to an R value. And I can point to the guy who is pointing to the neutrinos. This isn't exactly correct because that assumes that I'm pointing to the guy who is looking at the neutrinos. So he's here, I'm here, neutrinos here. I am pointing to him and he's looking here. So I'm only pointing to him. But in this case, he is the neutrino. So I'm actually pointing to him or something that is bound to him, not just looking at him. He basically is him. So it's different, but cool. Okay. I'm glad I got that to kind of work. I mean, what would that look like if we did just a test? Get some standard character output action. Oops. Oops. Excuse me. Const int reference. Excuse me, reference to X. Holy shit. Ate a lot of chicken and and salad. What is happening? I was gonna get Dr. Pepper earlier, but I was thinking about getting it. Ooh, I shouldn't. Health. But I can do a const int pointer to XP to X. And then, reference of X, where X is, because that's what pointers are. They store references, they store memory addresses. But then I can output, sure, I can output XP, sure, address of temporary value 5 is, temporary R value 5 is this. Value of temporary R value 5, or value at address of, excuse me, reference to temporary R value 5 is, we want this to be 5, dereference XP. Nice. The temporary value is stored here. And I can actually point to where the reference is that is bound to it. I can't point exactly to it, but I can point to a reference that's looking at it. Is that useful? I guess it is, because I'm effectively storing a temporary object, which is kept in lifetime. And then I'm pointing to where it is. So if I create a temporary object, but for some reason it's not assignable to something, it's too big, or I don't know, and I just want to store wherever the fuck it is. It takes enough effort just to create that bitch, just to assign it to wherever the hell it's created. Instead of creating it and then assigning it to a permanent object, we just create it and that's it. That's all we can manage right now. Like I pretend all of the shaders or something, the fucking million gigabytes in a stupid COD game is created and assigned to some temporary object. It's too hard to copy 60 gigs somewhere else. It's too much. So where the fuck are the 60 gigs? All right, we look We have a guy who's bound to the 60 gigs, so we can access the shaders at the 60 gigs. But I can't fucking look at them straight away because they're temporary. But I can look at the guy who's aware of them. Okay. Oh, with one exception, next lesson, initializing a pointer with a literal value is disallowed. Yeah, what was the error that it came up again for that? Was it the address of 5? Whoops. Is it? I don't know. What is the address? Or what is the error here? Oh yeah, it just says we're getting an address of a constant instead of the address of a binding to a constant, a reference of a constant, a reference of an R value, a reference to const, an L value reference to const of an R value, or bound to an R value. Yep. To change what the pointer is pointing at, we assign the pointer something else. To change what the value to change the actual value being pointed at, we dereference and assign the dereference guy. So x is pointing to y, which is an integer object. Therefore, x is an integer pointer. Dereference x is assigning value to dereferenced x, where memory is. Assigning value there. Oh, my stomach's gonna hurt. X, int pointer to x, output 5, which is what x has. Int 6, int y gets 6. Value list initialized with 6. Pointer now points to y, address of y. Output 6, 5, 6. Yes. Yes. X 5. Integer pointer points to x. Gets the address of x. Standard character output x 5. Standard character output value at pointer. Pointer holds x's address. What is that x's address? X's value. Therefore 5, 5. Dereference pointer now assigns 6. Now value that is at x. X's address is now 6. Therefore, x is now 6. You can indirectly change something. It's like, hey, I know this guy exists, and I could go and ask him to wash his car. Or I could call my buddy Jimmy, the pointer. He knows where Jimmy is. Or we got Jimmy and we got the guy. Or we got Jimmy. I don't like Jimmy. I know a guy. I can call this guy. He knows where Jimmy's at. And I can tell him to break Jimmy's legs. So we use the guy, the pointer. We say, dereference the shit that you are holding. I'm not going to mention Jimmy. We're not mentioning Jimmy at all. I'm mentioning the guy. You. Dereference. Change the guy you're looking at. Jimmy's your target. So it's like, guy, me, Jimmy, guy. Guy, here's your target, buddy. Look at Jimmy. All right. Dereference what you're looking at. Fucks up Jimmy. Now when we look at Jimmy, oh shit, Jimmy's fucked up. How? Ooh, we changed Jimmy using the guy who knows where Jimmy is. He went to where the fuck Jimmy was and knocked his ass out. It'd be a good idea for someone to put on like a whiteboard and then illustrate computer science, or I guess, I don't know, programming. I don't really understand computer science, but programming shit with mafia references or something like that. Yes. Well, yeah, it's dereferencing the pointer, yo. Ain't no damn type. We ain't creating no damn pointer. Like that I can highlight these. Excuse me. Yep, and then we go and take a look at x after we changed. It's 6. And we get the value of pointer, or the value that pointer is pointing at by dereferencing pointer. Boom. We get 6 too. 5566. Yes, sir. Cool. Well, all the shit's in the brain, so I don't think music is hurting it. So let's do this. What is this? It's one of those creations, Ross. Alright. Oh, shit. Oh, yeah. Who's the vocalist in this one? Yo, yo, yo. Who is the vocalist? Yeah. Here it comes. Oh, nice. Oh, yeah, let me make sure my videos haven't been blocked. What the fuck am I doing? YouTube Studio. Cool. Okay, not blocked. I just wanted to make sure that because I was looking at these videos for a little bit because I was turning music on, which took a while, and I was typing comments and shit yesterday. We define pointer, give it the address of some shit, print the value of x, the object of the name of that piece of memory, and the value of what's actually there. I can look in the car, or, well, let's see. I can open the big red container that has some shit in it and see, hey, what's in X? All right. Or we say, hey, the big red container, its location is what pointer's looking at. Hey, pointer, what are you looking at? Oh, or what value is where you're looking at? Boom. Not what are you looking at? That's the address. What's in there? Dereference that shit. It's an L value, therefore we can use it, we can assign value to it. Yeah, because we're pointing to an object. Pointing to a non-temporary object, an L value. Ooh, what happens? We need a const int reference, rather an L value reference to const, an int reference to const, x, and it's pointed to, or it's bound to 5, temporary value. And then we have a const int pointer to x. Oops, the address of x, so it can point at x. Can't just point at the value of x, because x evaluates to the value of x. I need to pass in the address of x. Cool. But then dereference XP is now 3. Uh-oh. It's not an L value. Cool. Oh, that's where I saw L value and R values first. It was in the fucking compilation errors. Gotcha. I wonder if anyone says compilation. Because dereferencing the pointer returns an L value, we can use this on the left hand of the binary assignment statement operator to change the value being pointed at, the actual value, to 6. It was a good song. It was kind of chill. We can then print X, which is the name of that memory there, and we're seeing what's there. But then we can also look at what's there explicitly by saying, this address, what's in the door? Open the door. I can go to mom's house and open the door, or I can say, go to the house at 23848 coordinates in the world. Open the door. Either way. We use a pointer without a dereference operator. Yeah, so it's going to say when we use a pointer without dereferencing it, we're changing the object it's pointing at. But if we use it with the dereference operator, we're changing what is at the address itself, what the value is. Yeah. And I guess it is always an object, because I guess we probably can't point at a temporary thing that will actually end, so we have to prolong the lifetime of it by binding a const reference to it. Yep, access the address held by it. If I modify it, yep. Sorry. When we dereference a pointer, we're accessing the object it's pointing at. Okie doker? Yeah, so if we say dereference pointer is now 6, we're changing whatever it was pointed to. Ooh! Can I do cooler stuff now with the targeting system? Maybe? Hold on. I can't remember if I was thinking that pointers were going to be needed. So what, we have a target? Oh! Hold on. Yeah, I don't think I need references. I just need 2 objects. And I have a pointer. And attack simply outputs the thing that's... Oh, yeah. Yeah. I think it was a pointer that I was needing. Because I needed to look at something and not be bound to it. I don't remember exactly what I was doing with a reference, but it's not a big deal. So I need standard string and I need standard character output. So I need IOStream because it needs standard character output. We also need string because it needs standard string. Well, I mean, maybe... Well, standard string's an L value, so I don't even think we need a const. I don't know, how do we get a reference to the standard, or to the C-style string? I'm not sure. I'll try that after this real quick. So let's do standard, let's fuck safety. Let's say fuck standard string. What if I say a const, oh fuck, what's the type? Do I want to do that? I don't know if I want to. A const character pointer, because C-style strings are objects, X, and it's pointed to hello, and it's the address of hello? Ah! Oh wait, hold on. Fuck. Alright, I don't know how to access C-style strings. Cannot convert a pointer to a 6 length because there's an n-length character there too. There's a null character at the end to terminate the string. That's why it's not just 5. H-E-L-L-O, null. Or n-length character. Well, yeah, null character. Or, null terminator, there it is. Alright, whatever. So, I do need a standard string to actually use strings right now. So, it's fine. It is what it is. For now. Until I can do some array stuff. Or at least with C-style arrays, I guess. And let's do some namespace action. Why not, huh? Targets. Sure. Yeah, why not? Oop, what the fuck am I doing? if not defined, targets H, define targets H, and if namespace targets const standard string orc const standard string goblin goblin. This should not be capitalized. Oh, this needs to include string, need standard string. This now does not need standard string because it's transitively included. It's going to be included in here, which means targets gets included here, therefore this code gets included here, therefore we don't need to double include. Targets.h, cool. Targets, cool. Alright, so I'm gonna say void attack target, attack target. Or we could say void set target. Either way, maybe. I'm using the wrong operator. Alright. Set target, we need a standard string. Current target, standard string, new target. Okay? And I could say proposed target, because new implies old, but... Oh, and... there's what the old target is, what the new target is, and then I'm actually updating the target. So we need a... Ow! What the fuck? Okay. These don't matter. I mean, I could make them const just so we don't change them. Standard string pointer called target. Current target. All right, let's say this is... I'm gonna say this is target. This is... Yeah, sure, we'll say old target. Okay. And we're gonna say... Oh, we don't need to pass it the old target. We're just going to say... Yeah, I don't need to tell my targeting system to untarget orc and target goblin. I can just tell it target goblin now. It'll automatically do the untargeting. It'll replace the value. Okay, so we're gonna just say, excuse me, target is now, it's actually super easy, no dereferencing even needed until we print. Target is address of new target. Easy enough. Well, I guess we could say what the old target was. Yeah, sure. Standard string, old target. Sure, why not? From old target to new target. Cool. All right. So we'll say set let's say standard string or const standard string pointer to a const standard string target value initialize. We'll say set target, and we're going to be setting old target, new target, and then the thing that's doing the targeting. That's fine for now, whatever. Alright, so we'll say, what was the old target? Well, it was targets. It used to be, oh wait, why is it still? I thought I changed that. Bro, I did it again. Okay. I'm just in the habit of using caps. Targets. Well, hold on. So... I'm gonna do that. Oh wait, what the fuck happened? Hold on. Oh wait, assign, sorry, not equivalency. Oh fuck yeah, nice. So now if we don't have an old target, I'm doing this now, fuck it. We have to do it this way. I needed there to be a default target. That way, if I didn't have if I had never set a target before, then, or hold on. I guess I could just dereference it, huh? Let's do that. Fuck passing the old shit. This is a better way. From dereference target. Okay, super cool. All right, nice. So, and we're going to set the target. What target are we setting? We're setting target to now get the address of new target, and it is now targets orc. Cool. And now we're gonna set target from, or whatever, we're setting target to now be targets goblin. And now we can attack, attack target, and it needs, I think, just a standard string pointer, right? A const standard string pointer target. Output player attacks. All right, well, let's say past tense. Player attacked. Sure. Sure. Dereference target. Cool. Oh, hold on. So target initially doesn't have anything, and we're saying from. Oh wait, hold on. Well, I need to say what happened first. So we're gonna say from whatever's there. Or actually we're gonna say current target, dereference target, new target. Alright, well, target set to, well, yeah, I could just say what's at target now. And this validates it too. So we're only talking about what we're pointing at. So, oh no. Uh-oh. So this is, I guess maybe that's why you want a null pointer, so that if you dereference it, it crashes. Okay, so this guy is set to point to nothing. He's set to point to 0, memory address 0. So when I try and print him, ooh, this was null pointer. So whatever the fuck this is, I don't see this, but I guess it's saying I guess return what you're pointing at, and it has some detail. Oh my god. My pointer? Jesus, who coded this shit? That guy's scuffed. Alright, well, can't do that. So, actually we'll say if we're only going to do this if target is not null pointer, I think. Or if target is not null pointer, because we can't compare the value, a standard string, to a pointer. We need to point to, or we're comparing a memory address, 0 probably, to a standard string. But now we're comparing an address to an address. If it is not null pointer, then it will do that. Else, output, or if it's not, or rather we can say else that, and we could say if it is null pointer, then output no current target. So, or yeah, we'll do it like this. Print target, print current target, update target, print new target. Cool. Print attack on set target. Cool. Oh, I made all those changes in debugging? Oh. So, it's set to null pointer, so we have no current target. Target is then set to orc. Oh, hold on. Why did it do it twice? Oh, hold on. Hold. Oh, fuck, is this a pass by value? Hold on. Do I need a reference to the pointer to pass the pointer by value? I think I'm only passing a pass by reference. I think that's what's happening. Well, I'm guessing that's what's gonna happen now. Hold. Hold. There we go. Yep. The problem here is we're passing. So we have a pointer to a standard string. And I'm passing this pointer. I'm passing the memory address to here. So now this parameter, this object, this other pointer, is pointing at nothing. Then it's pointing. But then once the function ends, the pointer's dead. All we did was print that the target was set. We didn't actually pass a reference to it. So we need to pass a reference to a standard string pointer. Oh my god. All right, hold on. A reference to, hold on. Is it as easy as this? Oh, wait. Fuck. Maybe not. Hold on. No target. Hold on. Target set to orc. Oh, wait, hold on. What's happening? Okay, so no current target. Target set to orc. Hold on. So we call to set the target, and we don't have a target. And then it says target set to orc. So isn't this though a reference to a pointer to a const standard string? Meaning that oh, and this needs to be not a pass by value, This is the issue. We're not passing by reference here. And then this needs to be, I'm copying by value the reference that it's looking at. Let's just do a reference. Uh-oh. Oh no, wait. Let's go, son. So we call set target and we have no target at first because we are pointing at null, baby. But then we call set we call set target, we're pointing at null, so no current target. We update the target and we're updating the actual reference. This target. Target looks like such a weird word. It really does not. Is that how you spell target? Target does not look like a real word right now. It looks like tar-get. Is target real? It looks like a damn Scandinavian word or something. Like something that a pirate would be saying. The pirate letters with squiggles and shit through them. And O's. Let me see. Scandinavian O. That! What is that? Okay, alright. It's got a plank in the middle. So O plank. Plank's O, plank's constant. Alright. So first we have no target, and then we are actually updating to point to where this guy is in memory. That const expression not in line. Uh-oh, not in line. Well, it is local, so I'm gonna make it inline because consts are local. So normally the linker would say, hey, you got a bunch of constant over here and some more const variables over here and over here. Oh, they're all unique, but no, link those motherfuckers so we're saving memory. Doesn't matter now because I only have one file using them, but if I had another file using them, we'd be kaput. So wasting memory by 100%. Fuck that. Current target. So the current target is nothing. Set the target to orc. Then set the target instead from orc to goblin. It should be current target, new target. I don't like this. We're just gonna say, well, no, it's fine because we set target. Target set to this, or set target to, I'm gonna say set target to. I don't like that. Set target to, and I don't really like the colon shit. No current target at first, then it's updated to orc because we're passing every guy by reference, and then we're saying, hey, current target is orc. Now it's being set to goblin. And player attacked a goblin because we updated the pointer target by reference. We were dealing with the reference guy. So we're changing the pointer himself by changing a reference to the pointer. Fuck yes. Okay. I gotta go to the bathroom real quick. Alright, that was sick. Man, eating salad makes you poop so much more. I feel like there might be some real rationale to not eating as many veggies sometimes just because, I don't know. Maybe it's true that the less you poop, the more of the nutrients you're actually getting out of stuff. But maybe it's also the case that pooping has some sort of cleansing effect going on. Asmongold. Alright. Yeah. 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 Yeah, we just did this. Yeah, I agree. When we dereference a pointer, we're accessing the object that's being pointed at. Yes. And we are changing the value of the object to something else. Whatever the right operand is, the R value. So, or an L value that's going to be converted to an R value. Consider this program, yeah, because we're gonna be fucking around with ref, so we can change. So we can say x is this, change x, x is changed, x, x, change x, x is changed, or change x through x, or well, x, change x, x has been changed, x, x ref, change x ref, x has changed, x, pointer to x, change x through pointer dereference, x has changed. 3 different ways. Oh, or in this case it's just printing, but we're not changing it. Okay, yeah. Yes, we are. Excuse me. X is 5, reference to x, pointer with x's address, print x, print ref, print pointer to x, 5, 5, 5. Change the reference, the x through the reference, x is 6, ref is 6, pointer dereference 6. We're printing x, we're printing the binding to x, and then we are printing through the binding, printing x's value through the binding because it's an alias to x, and then we're printing the value at the same address as x, which happens to be x, with the pointer. Or I guess the pointer is pointing to the object, so we look into the object. Oh, dereference the pointer in us, or assign value to the dereference pointer to change x because x is at the address of pointer, which isn't apparently known. Same with ref though. Output x for 7. Output the ref, the binding to x, 7. Output the dereference pointer to x, 7. So we get 5, 5, 5, 6, 6, 6, 7, 7. Yes. And let me read all the stuff. Read. Yeah. Normal value with, or normal variable value x, an L value reference to it, and a pointer to it. We can change it through the L value reference. We can change it, we can update it through all, or we can print it through all 3. We can access it with all 3, and we can change it through all 3. Dereferenced pointer. Pointers and references both provide a way to indirectly access the other object. With pointers, we need to get the address, and so we need to pass the address of the thing, and to access the value, we need to access the value at the location. But with the address, we just say, hey, bop, bop, is assigned x, but it's assigned, I guess, the address of x, and the reference. References must, references are only for one thing. We create a reference to a thing, and that's another way to access it and pass it around. But you cannot use it to be, you cannot reseed it, change it to another object. That reference is only ever found to that one guy, and then it is destroyed. Just like the love between penguins. Boom, boom, dies, dies. There's no boom, boom, dies, new, dies, dies. No, sir. Boom, 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 boom. References, yes. So I guess that stuff is happening, but it's implicit. Okay. The point is like a reference is a convenient pointer to one thing. It's like speed dial, but on a cheap ass phone that's a burner, so you can only ever put one person in that speed dial phone. Or I guess you could think of the burner as being a speed dial phone, and that's all it's got. You put one number in there, and it's done. When the guy that you're calling dies, you don't know who the fuck you're calling. It's a dangling reference. You can throw the reference away, and the guy doesn't give a shit. He doesn't see. You can get another burner and make it a reference to him too. Or you can get a new phone. Man, I'm getting good with these fucking analogies, right? Or you can get a smartphone or a high capacity phone. Fuck, I want to watch Breaking Bad now, man. Just cracking phones is so cool. I will. In my free time, I'm going to do that. Fuck watching this other media. I'm going to let Asmongold start cranking out some real videos. I love watching him talk about the gaming industry so I can learn more, and it's entertaining too. And politics to a lesser degree. But just to understand what's going on in the world a little bit and get some of his funny perspectives on things. I'm going to just go back on Netflix, start watching some Breaking Bad. That's what I'll do. I'll do that in my break in 20 minutes. And yeah, I need to rewatch it. I've only seen Better Call Saul once too, so that would be good. And then your high capacity phone, your smartphone, we'll just say a speed dial or a burner, and then smartphone. Smartphone, you can still only point to one person at a time, but you can pull it out and you don't have to. So, like, the second you open up your smartphone, you automatically have to put who you're going to call, otherwise, it doesn't work, or you can't get it. You have to buy it and say, this is to call this guy. And the IT guy, yes, I'm programming it like this. And he will put the phone number in and boom, you're good to go. But if it's a smartphone, thank you, Dave. If you have a smartphone, you don't have to. You buy it, leave it, and you put someone's number in it, and you can call that person whenever you want. Change them, tell them to do shit. Cool. You can remove them, put another phone in, remove it, do what you want. Cool. Reseedable, less convenient references, seems like. Pointers are also objects. Therefore, references must be initialized. Pointers are not required to be initialized, but should be, probably at least with null pointer, I'm guessing. References are not objects. Pointers are. Is it memory hex? What if I wanted to just do a pointer with a literal memory address? Do I have to point to an object? I feel like that's kind of inconvenient. Oh fuck, what do we do though? I guess you do, huh? Because you have to know what type of thing is at the address. Yeah, so I guess a pointer does have to point to an object. We can't just say, hey pointer, hey phone, there's a number, but I don't know who it's to. No, sir, you gotta buy the smartphone that matches the type of person you're trying to call. You want to call the hoodlums? You need to buy a hoodlum smartphone. You can call any given hoodlum when you want, one at a time. But if you want to call the big boys, you got to get a big boy phone. Can't swap. There's no pointer type conversion as far as I can tell. References must be initialized. Pointers are not required to. References are not objects, but pointers are. Unless I think unless we're talking about L value reference to constants. I think those might be objects in the case where we're bound to an R value, because we're storing the location of the R value, which otherwise might not be known. Maybe I think it's there was one case where a reference might actually be an object. References cannot be reseeded, but pointers can change to point to something else. References change what they're pointing at. References must always be bound to an object, and pointers can be pointed to nothing. Same thing here. It's the same case as here. References are safe unless the object we are bound to dies first, which might be rare. Is that rare? Object exists, reference to the object. If it's declared in the same scope, they both die at the same time. It's probably rare. Yeah, I mean, unless I have a reference to an object that's local, right? Because then the object and I'm returning a reference to it, then it dies and is dangling. References are safe outside dangling ones. Pointers are inherently dangerous. Yeah, as we saw. I was trying to dereference the fucking pointer to 0, so woo! Pointer to null pointer. You dereference that guy, you get a fucking standard abort, buddy. Actually, it wasn't even a standard abort. It was I think a failure to access memory. Like locked memory, maybe. Which makes sense. It's like, hey, instead of opening up the wrong fucking door, just try and open up the door that's fully locked and you can't open. It's better than accidentally opening up the fucking wrong door to the wrong place. Some psycho comes out. The address of operator returns a pointer. Like if you have to open up a door a night and there are only 5 doors in the place and 4 of them are unsafe, just fucking open, and they change each night except the one that's always locked. Try and open the locked one just to crash the thing without fucking other stuff up. Because maybe the other doors will have permanent impacts. The address of operator returns a pointer. So an address of something is a pointer. Or at least, yeah, I guess so, right? I am assigning an integer value. The value is an integer literal. The address of operator for some particular object is an address literal. An address literal is a pointer. Oh, it is not an address literal. It's worth noting that the address, and thus that's why we can't assign pointers integers or binary. It's worth noting that the address of operator doesn't return the address of its operand as a literal. C++ does not support address literals. It returns a pointer to the operand. So it gets a temporary pointer and copy initializes the value to the pointer that's named. This value is the address. Given variable int x, it's a pointer to x, not the literal address. An int pointer holding, okay. That is why we see ampersand thing, and then we see, oh, you're fucking around with a pointer. What? That makes sense. So we have 4. Type of x is an int. Type of data, address of x, pointer, int pointer. Mm. Hmm. The size of a pointer is dependent on the architecture. Oh, because yeah, that makes sense. Because memory, if there's a certain amount of memory, and there's a whole shit ton, we sorry, we describe it in a different way. If a building has if a building has 20 floors, it might be 01 through 09 to 10 to 11, so that everything is 2 digits because the whole way down is 2 digits. And maybe that's the case for 0 to 10, or 1, 0, 1 to 1, 0. So it might also be the case that, hey, if we have a taller building, we can have more floors, more memory, then we refer to memory as longer addresses because it can be a longer address. So maybe the first floor of a building with 100 floors is 001. Thus, the address of a 32-bit thing might be 000000000, and then the address. Whereas for a 64-bit one, for a small address, whereas for a 32-bit one, it might just be whatever 8 instead of whatever. Or I mean, I guess really it's 32 bits, but size is dependent upon the architecture. Okay. 4 bytes or 8 bytes? And it's true regardless of the size because the pointer is an address. Well, the pointer I guess somehow stores an address, but not just that. But it's basically an address, I guess. So it doesn't need to be any bigger. So we have main, we have a character pointer, an int pointer, and a long double pointer. And it's a 32-bit application. Even though characters are 1 byte, ints are 4 bytes, long doubles are probably 8. Oh shit, or 12. 12 bytes? 96? Holy shit. Huh. Size of each one is 4. Size of a pointer is always the same because it's just an address. Well, but not a literal. Makes sense. Gotcha. A dangling pointer because we have a pointer to something, but then we fuck with what's or we destroy the object it's pointing at, and then it doesn't point to shit anymore. Or points to, I guess, wherever it was, which is now a garbage pointer, maybe. Undefined? Oh. Yeah, undefined. Cool. Any other use of an invalid pointer has implementation defined behavior? Meaning? What are you talking about? Meaning, so as long as we don't use it, it's okay. I mean, it makes sense. We would still be able to override it. Or why is it saying implementation defined instead of just normal shit? Means you can assign an invalid pointer a new value. Sure. However, any other operations, copying or incrementing, are implementation defined. dereferencing, but incrementing it might change. So maybe it by default sets it to null and then increments it. We don't know. Okay. Creating a dangling pointer. So we create X, we create pointer to X. Oh, and then we're going to change it to be pointing to Y, and then we're going to reference pointer. Okay. Is there even a point to having X here? We may as well just say pointer exists. Okay. Oh, well, I mean, I guess the point is that you're showing what the pointer has at first. Because you can't, if you do null, you can't dereference it. So the point is you're showing the dereferencing. Okay. And then you say, hey, point to Y. You're pointing to Y, 6. But then, Y is dead. What are you pointing at? Excuse me. Oh my god, the burps. Oh. Pointers are variables that hold a memory address. We can't see the memory address, maybe. They can be dereferenced. Can we get the address, though? Where's my music? Well, I'll just see if we can static cast it. Fuck! Ah! I need some address shit, man. I need a binary uint. Oh wait. I wanted the address, yo. Yep, to get the value that they're holding at the address that they're holding. It makes sense. Well, probably because the application is going to be doing something to something that's dependent on something else, and oh god, maybe. I think might crash your application is probably better. Pointers are both more flexible than references and more dangerous. Yeah. What does it print and what's wrong? Let's do backwards. Fuck it. All right. Am I retarded? Int v1. Oh! You're dereferencing him, motherfucker! We have an integer here. We have a pointer, and we're initializing him with this boy's address. v1's address. Pointing here. So if we printed dereference pointer, we get 45. v2. But then you are changing v1 because you're pointing to v1. You're changing the value at the object at this address at v1 to be the address of this guy? Oh no, that's not gonna work. You're changing the int to be a pointer. Oh nah. Yes, exactly, makes sense. The first and fourth are standard declarations along with an initialization value. Cool. Second line, the asterisk is part of the pointer declaration syntax. Cool. Yeah. On line 5, a dereference. Assign the address of v2 to the value pointed at. No, sir. You can't assign an address to an integer, a pointer to an integer. Exactly what I said. Fantastic. Pop. All right. What's happening? What does it print? Oh, motherfucker. I don't have time. Short. 7. Okay, what are we doing? Pointer to point to value. 7. Excuse me. We're outputting the address. 7. Inline. Pointer is now 9. 7. Value is now 7. It's still just the address of value. It's now 9. The address of value probably still the same. 9. Next. Pointer's now other value. It's the address of other value. Same thing here. Other value is 3. Outputting other value 3. Inline. Size of pointer is whatever the fuck size of pointer is. Assume what? 32-bit? Okay, size of pointer 4 bytes. The size of dereference pointer. Other value is a short, so 2, I think. Did I not turn on my alarm? Oh my! I fucking forgot it was 1 minute late. Oh my god. Okay, I'll check my answers here in a sec. We'll do question 1. Cool. Done for now. Time to watch Breaking Bad for 30 minutes until we are back on. This whole alarm system has been great because I'm not bored, but it feels like I need to be on schedule. It feels like in the Andor show, there's a part where a character is in a prison. And there's a terminal here that's on program, where all the guys will hear on program this announcer, and they have to put their hands like this so they don't get fucking killed and shocked to death from the floor because they're standing on this electric floor. But it's not always on. It's only on when they're trying to mess them up. And they do that. And then they go and they do their work. That's what it kind of feels like, but it's a good feeling. It's like I'm being forced to work. I like it. Instead of being a bitch ass. All right.